Today we are going to discuss about one of the primary piping design deliverable, which is known as MTO. So we are going to discuss extensively about this topic in this video. So here I am with you, Subhash Chandran from Pymedaca. Without wasting your time, let's get started. So today we are going to cover several topics in this particular discussion. We will start with what is MTO, what is BOM, why it is required, and what are the skills required to prepare MTO, and how to prepare MTO, and what are the different types of MTO. So we will cover all these topics in today's video. So let's get started one by one. So this is our topic MTO, and in this topic we will discuss about all the subtopics, which are what is MTO, what is BOM, why to prepare an MTO, what are the skills required, types of MTO, and how to prepare an MTO. So without wasting your time, let's get started. So let's start with the first one. What is MTO? MTO is nothing but material takeoff. That is what the full form stands for, MTO, material takeoff. So what is it about? It is nothing but a document with a list of materials required for procurement. Basically, you are preparing a sheet which will have a list of materials with quantities that will be sent for procurement for further purchase. So in order to get an idea about what this document is about, let me show you the sample document over here. So this is a particular MTO sheet which is prepared for a particular project actually. So this consists of a list of materials which will be procured by the procurement team. So how many number of line items are there? There are nearly 76 line items are there. So you will be preparing an individual MTO sheet for each project. So which will be further forwarded to the procurement team, by which they will be able to procure the items actually, basically purchasing the material. So let me just show you what are the informations available over here. It starts with the serial number, an item name, and size, and spec, and descriptions, and materials, an item code, and actual quantity, and spare percentage, and spare quantity, and final quantity. Let's talk about this details in a much more detailed way in the upcoming slides of the video. So without wasting your time, let's go to the other topic so that we'll be able to understand about this MTO much more before discussing about this topic in a much more detailed way. Okay. So now let's move on to the next slide actually. What is the next slide? Next slide we are going to discuss about what is BOM. What is BOM? BOM is nothing but a bill of material. There is always a confusion about the BOM and an MTO. What is BOM? BOM is nothing but a bill of material. What is MTO? MTO is nothing but a material takeoff. But there are huge difference between these two. BOM is nothing but a list of materials shown in the side of an isomatrix required for construction for the given drawing. So you got to understand these two things. MTO is a list of materials that will be sent for procurement, but BOM is not a list of materials that will be sent for procurement. BOM is a list of materials indicated in the side of an isometric drawing which will be used for the purpose of the construction actually. Let me show you a sample of an isometric over here. So here I have just kept a sample of an isometric from internet. See, this is one sample of a piping isometrics. You can see a piping, a drafting over here, the line over here actually, and at the same time you can see the list of materials over here. This list of materials are the number of materials required only for this particular line. So this list of material does not include any of the continuation part of the piping actually, but MTO is not so. MTO is a material that consists the full list of quantities for the entire project, but bill of material is only list out the materials which are only intended to be used for this particular line actually. Generally, bill of materials are referred by a construction team like a fabricator and the piping supervisor to check whether these materials are available in order to install this particular portion of the piping actually. Likewise, they will be going around to find all the materials which are required for each individual drawings basically. So that is the major difference between an MTO and the bill of material that you got to understand. You should not be confusing between an MTO and the bill of material. Okay. So let me go to the other topics, and if you guys have any confusions about the bill of material and MTO, you can always share your thoughts in the comment box and I will respond you. Now let's go to why to prepare what is the basic intent of preparation of this particular MTO? So basically we are preparing for the ease of procurement. Okay, without the list of materials, do you think anybody can go and procure the items? You need to have the specification, you need to have the detail of the materials in order to procure, right? So let me understand that in a much more detailed way. So imagine that you have developed set of drawings, set of isometrics for piping. Okay, and each of these isometrics you got to have a bill of materials which will show you the list of materials required for a particular line. So do not have any confusion. So we are discussing about an isometrics with a bill of material as a drawing over here. Imagine you have prepared those drawings. Now how to procure an material for those drawings? So without MTO, how do you think one can go and procure? So you are going to prepare some material list, right? So this material list will consist of the materials which are included in all of these drawings. So you are going to list out all this material in one particular document, and this particular document will be going to the procurement. So that is how it works actually. So if you don't procure these, if you don't list out these materials, and how do you think the procurement team will procure actually? So basically it's a responsibility of a piping design engineer who will collect the list of materials from all these drawings, and he will put it in this material sheet which is known as MTO. And this MTO will be going to the procurement team for further purchase of a material. There are some advantages. I'm seriously telling you about this. Okay, the advantages are that, see, once you prepare a list of materials, you will be able to ensure that the material specification you have captured correctly, so that procurement team will be avoiding the purchase of a wrong material. Otherwise they may be referring some documents which they may not be able to interpret, and they will be purchasing something wrong. So to avoid wrong purchase, it's essential to have a list of material. And then exact quantifications actually. So when a design engineer prepares a particular drawing, he knows how many number of fittings or how many number of pipes are actually required. Okay, procurement team may not be able to understand that actually. So if you prepare a list of materials, you will be able to exactly quantify the material. So you will be able to understand the figure is correct as per the design actually. So if you don't have the figure, and how do you know that how many number of pipes are required? Because you have 10, sometimes you will have 10 drawings, you will have 20 drawings, you will have 100 drawings. So unless you quantify all of these drawings actually, you will not be able to know actually. So it's really important to quantify it. So this list of materials will consist of the quantification. So that is why it is very important to have this document that will avoid some quantification issues actually. Now let's go to the next point. Makes checking easier. I'll tell you why it is. Because when you have listed down all the materials, if you go back and check with respect to your drawings, you will be able to know whether you have particularly listed this material or not. See, if you have not done that, how even if you miss some of the materials, you may not be able to check it. So checking is one of the criteria where you will have to ensure in order to proceed for a procurement actually. So generally it's a part of a piping design activities. By all piping design engineers does it actually. That is the one of the reason why these documents are prepared. And then controlled follow. What is controlled follow? Let's say that you have listed a material actually. Now if something goes wrong in future, somebody says that you have missed this item, if you have this is not there in the drawing or something, you can really go back and check whether this item is really not required or not. So for that, this document will be really required. If there is no such documents available, you will not be able to justify your claim. So if you have a document in hand, you can always follow up on those items and check whether it is taken to consideration or not actually. Now let's go to the next one. And this document helps to pre-plan the construction activities. I will tell you why it is actually. See, when a construction contractor picks out a piping isometric, he will ensure the bill of materials, right? So he will go and check whether the bill of materials are available, because what is bill of material? Bill of material is nothing but a list of drawing materials which are required for one particular line and or one particular drawing actually. So he will ensure these particular materials are available. So once he ensures these particular materials are available, he can directly go for a construction of that particular line actually. So that is why this document is a vital document. So material planning and construction planning and pre-planning those activities is one of the vital activity in piping construction field. So they can only do it if they have the information in hand. The information in their hand is very important to have it actually, and piping material is one of the critical information that they need to have in order to check the material quantities so that they can go for the construction easily. So now let's go to the next one. Let's discuss about what are the skills required. So the skills required, it's basically, as a piping design engineer, you must know how to read PMS. PMS is nothing but piping material specification, or there are companies they call it as a pipe spec, and there are companies somebody calls it as a piping class. So PMS is basically a piping material specification for a particular project. In a project you may find more than 10 piping spec or more than 20 piping spec. It depends upon the number of types of materials available actually. So basically you must be conversant in reading the PMS. And then you must know the piping materials description. So what are the descriptions used for a pipe? What are the description used for an elbow? What are the description used for a weldolet and flanges and valves? You really have to have familiarity in knowing these materials descriptions actually. Then international material standards. What international material standards are used for this particular item, and what international material standards are used for pipes and fittings and flanges. So this you got to have it actually, and you need to have a good Excel skill. You really don't need to have an advanced level of Excel techniques or the skills. You just need to have a reasonable Excel idea so that you will be able to prepare a clean worksheet which is required for an MTO. And then you need to have some prior experience. I understand that for a beginner it is really hard to immediately prepare as a fresher into the field actually, but if you have some little guidance for a couple of projects, you will be able to understand the importance of MTO and how you have to prepare an MTO. There are some things that you have to do in MTO that you will be coming to know during the experience. So if somebody is able to guide you during the experience, during your workplace, so you will be able to gain more knowledge faster than doing the self preparations actually. Self preparation is must, because in self preparation you will be able to realize that the things which are really important for a work, and you will be able to spend time to understand and give time to observe the knowledge from this particular domain. So I would say the experience also matters and self preparation also matters actually. So basically these are the skills required for MTO. So now let's go to another slide. Another slide is different types of MTO. How many different types of MTOs we have actually? See, basically we can say there are two different types of MTO. One is preliminary MTO and another one is final MTO. And what is preliminary MTO is about? Preliminary MTO is about an MTO which are prepared at the very beginning stage of the project. And final MTO is about an MTO which is prepared after issuing an AFC. AFC is approved for construction. So there are two different requirements are there for preliminary MTO and as well as final MTO. So let me tell you why preliminary MTOs is prepared. See, preliminary MTO is nothing but you got to prepare a list of materials at the initial stage of the project so that those materials can be procured. Generally, material delivery takes a lot of time. Imagine if you prepare an MTO which is at the end of the project and send for a procurement, and the material delivery guy says you will receive the material only after 3 years. So you will have to wait for 3 years. But at the same time, if you can start the list of materials at the beginning of the project, imagine that your project has gone for nearly 2 to 3 years. Okay, so by the time you complete your project, you will be able to receive most of the materials. So that is why preliminary MTO is one of the important MTO, because that is going to play a key role in the duration of the project actually. If you miss any critical items in the MTO, it is really going to lag in the particular project actually. So, but there are other chances also possible, like if you miss something in the preliminary MTO and during the advancement of the project you found there are lots of materials which are really critical was missed actually, you can send an interim MTO which is known as intermediate MTO. Intermediate MTO is issued somewhere in the middle of the project or just before the middle of the project. It need not to be exactly at the middle of the project. This MTO is issued whenever you feel that there are more number of items needs to be procured and these items will take longer time. So the difference between all of this material, it's basically to save the time. So if you see that preliminary MTOs are issued to save the enormous amount of time for the material delay, and intermediate is issued when there is a huge amount of difference between preliminary and the actual actually. And final MTO, definitely there will be some changes in the AFC drawings from the beginning of the project, right? So you will have to add a few gaskets, bolts and elbows and pipes, maybe some additional you might have felt actually. So final MTOs should be an MTO which will reasonably be in a very smaller quantity. So even if there is a delay of this material, there will not be any much more delay in the construction completion. So you got to manage this MTO in such a way actually. Let me show you an example of a P&ID. Okay. Here I have an example of P&ID. Okay, let me just tell you how to take the preliminary MTO. Okay, let me just take down the notepad over here for your reference actually. So I'll tell you how to take the preliminary MTO with reference to the P&ID. Okay, but before that, let's understand what we are going to do it. So this is the line. So the clouded portion is our new line. So from this line, we have to send a preliminary MTO. How to send a preliminary MTO? By looking at the P&ID. So here you have not conducted any piping layout study, you have not conducted any pipe support study, you have not conducted how many actual footings are required. So here your intent to develop the MTO just by looking at the P&ID. So we can do that in a very much more simpler way actually. Let me just tell you how it is. First, understand this line actually. So what is this line? This line is a 10-inch line, right? This is a 10-inch line. From 10-inch line, you have another 10-inch line. So obviously there will be a T over here, right? So you consider a T, and then you have a line that goes directly into the valves. You do not know how many number of elbows are there in this particular length. So what you can do is that you can have a conceptual check in the layout, and if there is no layout, you can consider a minimum of at least 2 elbows. Okay, but if you have the conceptual layout in your hand, then it's easy for you to quantify the actual number of elbows actually. So you will be able to consider at least a minimum number of elbows. So if there is no layout, consider a minimum of 2 elbows. Okay, then you have a flange, then you have a valve over here. Definitely at either side of the valve you will have a flanges, right? And the flanges requires bolts and gaskets. And then the line goes straight and you have a 3/4 connection. In 3/4 connection from 10-inch, if 3/4 connections are taken, it is taken with elbows, it is taken with wallets, right? So you will be either using a couplings, half couplings, or you will be using a wallet. So wallets are the standard one. You can consider a wallet over here. And then you will have an extended portion of piping, which is a nipple. Then you will have either a flange, or if this is a socket weld valve, you will not have flange, and you will have a plug over here. So this is how you have to take the MTO. And then you have a reducer, then you have a PSV, and then you have another reducer, and then you have an again 3/4 valve and 10-inch valve, and then you have a line. It goes for a T actually. So this is how it is. You have to understand. Now let's list down what are the different types of materials required actually. So from here we can see actually what are the different types of material. So anyway, in order to modify the line, you need to have some pipe also, right? So I am taking a pipe as a consideration. Okay, so let's take pipe. Okay, pipe I need to have. Okay, if you have the conceptual layout in hand, you will be able to understand how many actual number of length. Otherwise, by looking at the actual piping layout and finding the location of this particular 2 tie-ins. Okay, if you find the location of these 2 tie-ins, you will be able to understand how much length is required. So let's approximately, if you find that 15 meters are required, then you have to convert this 15 meter in terms of 6 meter length category. So it will be an 18 meter. So 3 6 meters will be available, right? So pipe, I am considering 18 meter. Now definitely I will have elbows. So elbows, I will consider 2 elbows for here and 2 elbows for here. Okay. But if you have the layout in hand, you will be able to exactly consider the number of quantities. Then you have to consider a T. How many number of T's? Here we have 1 T and here we have 1 T over here, right? Okay. So there are T's. How many number of T's you have? You have 2 number of T's. Okay, 2 numbers. And now what do you have? You have to have flanges. How many number of flanges we will have for 10 inch? Let me just write the size also over here. So this is a 10 inch size, 10 inch NPS. This is a 10 inch NPS, and this is a 10 inch NPS, 10 inch NPS, okay, and this is also a 10 inch NPS. Fine. Okay, now let's go to the flanges. Flanges, I have 10 inch NPS, okay. So how many number of flanges? We only have 2 valves, 2 10 inch valves. So definitely there are 4 flanges are there. So 4 flanges I consider. Then you have how many number of reducers? 2 reducers. Okay, one is 10 into 6 and another one is 10 into 8. So reducer 1 is 10 into 6. It is 1 number, and another one is reducer. It's reducer. Okay, and another one is reducer with 10 into 8 of another 1 number. Clear? So we have taken up to the reducer. Now let's consider the 10 inch valve. Okay, 10 inch valve, you consider the valve is a critical item. You have to consider the NPS, 2 10 inch valve numbers. Fine. And now you consider how many number of any other fittings are there? No, nothing. So this is fine. So now you only have to consider the 3/4 inch connection. So 3/4 inch connection, you consider the weldolette. So there are 2 3/4 inch connection weldolettes. So this is 3/4 inch connection. So 3/4 inch NPS. So you got to consider 2 numbers because you have 2 connections over here. Then you may need a nipple. You consider a nipple of 2 numbers. Okay. Then you consider a gate valve, which is of even this also a gate valve. By looking at the symbol, it's a gate valve, right? Gate valve of 3/4 inch sizes, which is of a socket weld type, is going to be of 2 numbers. Okay, and after the gate valve you will have a plug. Okay, the plug also will be 3/4 inch size, NPS. Okay, NPS is a nominal pipe size, and you will have 2 numbers. Okay, okay, and we have a few more. So here we have a PSV, right? PSV we have to purchase separately by using the data sheets and everything. It is generally not included in the MTO, but however we will consider the PSV as well as an MTO because that is to be procured, otherwise you will miss, right? So here we have a PSV. What is the size of PSV? Here it is 6 inch and here it is 8 inch, right? So it goes into 6 into 8, 6 into 8. The numbers are directly not given here. That is how you have to convert. Okay, it is a one number, but you can put it in the bracket by data sheet purchase. Okay, data sheet purchase. Fine. Now for the PSV you need to have a flanges, right? So you need to have a flanges of 6 inch over here and 8 inch over here. So gaskets and bolts also will be required actually. So flanges of 6 inch NPS. Okay, how much it is? It is 1 number. Then the flanges of 8 inch. Okay, NPS. How much it is? It is 1 number, right? Then you have the respective let me put it. Then you have the respective gasket of 6 inch NPS of 1 number, right? Then you have the gasket of 8 inch NPS, 8 inch NPS of 1 number. Okay, or 1 number. Then okay, so we have considered everything except the studs and bolts. For studs and bolts there are some tables available from where you will have to find the size of the studs. Accordingly you will add the numbers. So this is how guys you have to prepare the preliminary. So now we have listed a preliminary MTO for a particular scope. So from this it is very obvious 90% of the material we have already procured. So even if there is a short of some materials, actually there will not be major delay in the project. So this is the importance of the preliminary MTO. So these preliminary MTO will be listed in this way with much more detailed informations and everything actually, and then it will be sent to the procurement team. Okay, so that is the very intent of this preliminary MTO. Then we will go to the final MTO. Final MTO is after the AFC issues, and then the intermediate MTO. Intermediate MTO is something that, as I said, you will be delivering in the middle of the project whenever you feel there are lots of materials are missing actually. So that is the very intent of the intermediate MTO. Now let's go to see how to prepare an MTO sheet. Okay, now let me just get into the sheet again actually. So now let's discuss in detail about this particular thing. What is the MTO? Okay, this is how the MTO is prepared, right? So here you have to start with the serial number, fine, and then item. You have to understand what is this item is about. Okay, so item is nothing but what are the different components available. Now here if you see the filter, okay, so let me just filter out a pipe actually. Okay, let me filter out a pipe. So in this particular MTO there are these many pipes are available, okay, of different sizes. So these are number of sizes which are taken from the P&ID. Okay, and this is a piping spec. What is the piping spec actually? If you refer the P&ID, you will be able to find what is the piping spec is about actually. And every P&ID has got a spec name. So for example, if you take this particular P&ID, you can see it is HC35. So this is the spec name actually. So there are companies that uses a different alphabets though, so this alphabet may change, but you need to open this document to understand what the material is about actually. So now let's go to this description. So this description you will be able to make out from the piping spec, but there is a challenge over here. In piping class you will have a detailed description. Here it is not intended to put the detailed description. That is why if you look at my previous slides in the skills, I said piping design engineers must know about the description of the piping, particular component. So here let me just tell you the description of the pipe. This is pipe, okay, and now SMLS. SMLS is nothing but seamless pipe. So if it is a welded pipe, you have to mention it as a welded pipe. Then the schedule XS. This is a XS is the type of a schedule used for a particular size of a line as per the piping material specification. And PE is nothing but a plain end. So this description you must be well aware about so that you will be able to convert it into the MTO. So if you do not know these descriptions actually, you will be putting all the bigger descriptions. I mean the space will be consumed in the MTO. It looks more congested actually, and there are times that it may confuse the procurement officers also. So it's better to put the short form so that they will be able to understand the type of material to be procured. And now let's list down the material group. What is the material type that is generally being procured actually? So this is a carbon steel, so you have to indicate the carbon steel material. And item codes. Every company has the piping class, and in the piping class they will have some unique code. You have to use that unique code. So this unique codes varies with companies to company, but you can find this unique code easily from the piping material specification. Now we will list down the actual quantity required. Like let's go for this example, like whatever quantities that we had listed, imagine that you have mentioned it over here. So this is the actual quantity. So what is actual quantity? Actual quantities are quantities which are exactly required in the piping. But what happens during the progress of the project if anything goes little higher or lower actually? If it is lower, that's fine, but if it is higher, then you may need an additional component, right? For that we have to consider the spare percentage. Generally for piping 10% is generally considered for as a spare. So here 36 means we will consider 10%. So 10% of 36 is 3.6. But we cannot buy a 3.6 meter from outside. So generally industry supplies in 6 meter length. Okay. So if you want anything more than lesser than 6 meter, you have to buy 6 meter only. Let's say for the example, if you want to buy a 7 meter, you cannot buy 7 meter. You have to buy 12 meter. So it will be 6 plus 6 plus 6 plus 6. So that's why when the quantities were lesser than 6, but still the spare quantity I have considered 6, because we cannot buy for a pipe, we cannot buy more than lesser than 6 meter. Let me just correct over here. This is also 6 meter and 6 meter, right? So for any materials, if it is a pipe, you can only buy from the 6 meter basis from the industries. So basically you will increase at 10% and see whether the 10% it comes in 6 multiples or not. So let's, for an example, here it is 36. Imagine this 36 is somewhere around 60. Okay, so 60. So what is the spare over here? Spare is 6. So I don't have to buy anything extra. 60 plus 6 is fine. But since it is a 36, so I am buying, it is a spare is more than more than the actual requirement. So that is how the final quantities are derived over here. Likewise, you will have to find different quantities over here and material group over here. So here you have the stud bolts, you have the OLEDs, you have valves, and you have gaskets and everything. Here, especially if you look at the piping materials, for a gasket, let me show you actually. Alone for a gasket, we used to consider 100% spare. What is 100% spare in the sense? You will exactly buy the same quantity of actual quantity, because there are times that during construction the gasket may get damaged, so we cannot stop the construction for the purpose of the gasket, right? So because the gasket, since it is a cheaper quantity also, you can buy in surplus and it can be used in future also in multiple purpose. So that is why gaskets are bought as an 100% spare actually. And there are other items also, other items since there are bolts actually. Okay, the bolts are bought by 20% extra, which is this 0.2 is 20%. So generally pipes are bought 10% extra with extra spare, and the gaskets are bought 100% with extra spare. And I can list down over here, the pipes are bought with a 10% with extra spare. Okay, and gaskets are bought with 100% extra spare. And stud bolts are bought with 20% extra spare. And this is a common philosophy, but however this philosophy may change with respect to the company's action. So if you are working in a particular company, don't blindly go with this philosophy. You have to check the spare percentage. Sometimes there are companies call this spare name as a contingency also. What is this contingency? Contingency is nothing but it's a spare, the excess material which are procured for the safer purpose of the construction. Okay, so this is the whole the features of the MTO. So the MTO preparation, it's not a big task, but it's a time taking task. You have to ensure all the descriptions are right. If anything goes wrong, and your material will be lost actually, you will be buying a wrong material. So that is one of the purpose why the MTOs are given a much more consideration. So this is all about an MTO, guys. I hope this video has helped you to understand about the MTO. I will meet you in another fantastic video. Until then, bye from Subhash Chandra.